Netcasts you love.
From people you trust.
This is TWiT.
Bandwidth for TWiT specials is provided by CacheFly at CACHEFLY.com.
This is TWiT Live Special number 258, recorded September 25th and 26th, 2015. World Maker Faire 2015. This TWiT Live Special is brought to you by Braintree. If you're working on a mobile app and searching for the right payments API, check out the Braintree V.0 SDK. With one simple integration, your customers get every way to pay. To learn more and to try out the sandbox, go to BraintreePayments.com/TWiT. The call went out. Makers of the world, unite. And so they've come here to New York City. I'm Father Robert Balaser, the digital Jesuit with TWiT TV, here at World Maker Faire 2015. The greatest show and tell on Earth. Computers have gotten faster, 3D printers have gotten cheaper, and scanners have gotten more accurate. But what happens when you need to interact the physical world with the digital world? That's the problem that HP is trying to solve with Sprout. I'm speaking with Judner, who's going to explain what Sprout does for the Maker. Judner, thank you very much for speaking with us. What is Sprout?
So Sprout is basically a computer that allows you to scan anything in the real world, and it'll show up on the computer in the digital world, and allows you to make any edits or changes you want to that device or product, and do whatever you want with it, and then print it out once you're done.
Now, that's one of the holy grails of the Maker community, the ability to take an object, a physical object, put it down, scan it, and then modify it and reprint it. There's been a couple of interfaces, a couple of tries, but most of them have been a bit clunky. Can you show us what HP has come up with?
Sure. So here we have it. You have a pad here that you can place any object on. So with this, you can take something like any object, you can hit capture. So for something like this, you'll just place it here on the pad, and once it shows up, you can actually see it start scanning, and then it'll pop up on the actual computer so that you can go ahead and make your changes, make any edits to it. This is just a simple picture, but you can actually check it out down here as well. So you can see it's the actual size of this. So you can go into here and make any edits that you might want. So if you want to do a 3D image, you can actually just go and do a 3D capture right on the map. And then you can actually choose if you want a 3D snapshot or if you want a full 3D scan. So with this, I usually do the 3D capture. Now you can actually use the 3D capture stage, which makes it a lot simpler. It's a base it's actually this base right here that allows you to take an object and it'll spin it around for you and allows you to make any of the edits that you want to do. So for now, I'm going to go with a manual scan. And then all you have to do is place your object down right here. So something like this. You can see it automatically show up. And then you can hit Start Scan. And then what it does is going to start actually scanning it. And you're going to see a bunch of different sensors go off. And then it's going to show up on the screen little by little until it's actually done.
So this is doing all the slicing for me. It's great, and it will tell me to spin it so that I can get a different perspective, and it will stitch those together. Now, question. What kind of system do I need to run this? Is this a specialized computer, or is this going to be a package that I can buy from HP and connect to my existing computer?
Well, this is actually a full package right here. This is actually the Sprout computer. I don't know if they are going to make any add-ons, but as of right now, it's all one package. You get everything that you need to actually start scanning. You get the mat, the computer, and the cameras, everything you need.
And then this will output in the files that I would need, like STL files, if I wanted to 3D print whatever I've captured and edited.
Yeah, and you can actually import those files into other programs so that you can do other things depending on the application that you want to use. So it gives you a lot of versatility.
Judner, thank you very much for sharing this technology with us. Now, if people were interested in finding out more about Sprout, of course they want to go to the HP website, they want to see all the information that HP has published about Sprout, what are you looking forward to? I mean, hopefully you can get your hands on one of these and really start putting it through its paces. Where do you see this technology being used?
Anywhere in the creative field. I think that anyone who wants to go ahead and make art concepts or projects, this is going to be a perfect application for them. Even me, I do video, but I still find I can find uses for this. and through using props, making props out of everyday objects, anything that you want to use your brain, you can use the Sprout for.
Thank you very much. And again, that's the HP Sprout. Imagination doesn't grow, it sprouts. We often talk about the spirit of the maker, and there are very few people who are more associated with that spirit than Dale Doherty. I'm standing next to the man himself, the co-founder of Maker Faire and the founder and executive chairman of Maker Media. Dale, thank you very much for speaking with us.
Hey, thank you. Good to be here.
Oh, Dale, I'm sure one of the questions that is on the mind of our audience is, why Maker Faire? Why create this event where you're bringing together such disparate types of people into one location?
Yeah. Well, I think there's a couple of answers to it. One is in some ways that's what fairs are. They bring people, old county fairs, art fairs, craft fairs, science fairs. They all bring people together who are doing sometimes the same thing, sometimes different things. But we thought it'd be really interesting when you look at what people are doing. It's kind of like the internet. There's someone doing something really specific. We wanted to kind of create a big tent where everybody could come in, celebrate what they make and talk to other people. It's show and tell. And, I just really wanted to see what people were making, what they were doing. And that my feeling was there were more people in our community doing that than we had any idea of. And Maker Faire kind of proves that.
You've got artists, you've got tinkers, you've got engineers, you've got business people, and they've all come together in one place. Well, how does that equate trend?
Well, I think making is still kind of something on the edge, and some degree the maker movement is trying to, meaning it's a subculture. It's something that some people know about. People come up to me and said, nobody knows about the maker movement in my community. And I go, well, that's too bad. Tell them, just start talking about it. So not everybody knows this. And in ways, what I see Maker Faire, we're trying to engage people as producers, not just consumers. So they see themselves as creative and contributing to making the world better, right? Even if it's their own life and doing something they love doing, like a hobby, or it's working out in the community and organizing this, it's really something that they are able to do, and it's the sense of agency that they have. It's the sense of belonging that they have, I think, in the maker community that really drives this.
Let's talk about that sense of belonging, that sense of being productive rather than just consuming.
Right.
One of the things that has really changed the maker scene has been the emergence of fast prototyping tools and very inexpensive tools that allow me to create things that otherwise I would have to manufacture. We've also seen this movement from hackers being just people who work with computers and electronics to people who can hack things in the real world, not just electronics, but in lifestyle itself. What do you think Maker Faire does for those people?
Well, when I came up with the idea for Make Magazine about 11, 12 years ago, it really actually was that idea that we would start hacking the physical world the way we hack software. And that why should we just limit ourselves to what we can do on a screen? But what about our car? What about our home? What about the lighting system in our home? My first name in my head for that magazine was Hacks. And I was really interested in the idea of hacking the world. But I really wanted to reach a bunch of people that didn't identify as hackers. And that's what I got with Make and Makers. I want people that do embroidery, that do use sewing machines as their platform. And I wanted to get people that are doing ceramics. I wanted to honor people that do food. And all of us, in our culture, making is there, but we don't celebrate it. We don't elevate it. And that's explicitly the purpose of Maker Faire, is to kind of raise it up so we can see it. And then we can see that each of us has a role to play in doing something.
Dale, I want to thank you so very much for speaking with us. Thank you for putting on these events. Now, of course, the best place to see the spirit of the maker is to come to a Maker Faire or a mini maker. Is there someplace else they can go to find out more about Make Media?
Sure. Well, I think they go to find about Maker Fairs, makerfaire.com, and if they want to follow the content from the community and like what we publish, makezine.com is a great place. But on makerfaire.com, we have a list of all the fairs. Any given weekend from, say, March to November, there are multiple Maker Fairs going on around the world. And we had 131 of them last year, so there's got to be one close to you, even if you're not near New York this weekend.
It's Dale Doherty, the man behind the greatest show and tell on Earth. Stereolithography. No, it's not just a tongue twister. It's what you want if you want the best type of 3D printing possible. I'm standing next to JP Shipley from Formlabs, who, well, they've just announced the Form 2, and it's going to change what you think is possible with your 3D printer. JP, thank you very much for talking to us. This is the new Form 2. Tell me what it has over the Form 1.
Well, the Form 1 was more of an analog machine, so you loaded the resin by hand, you had to connect to it via USB, and if you started to run low on resin, you'd have to pause your print and refill. This is much more reliable. We've actually reduced the stress on printed parts by having a horizontal slide peel rather than a hinged peel, which can stress some parts and cause print failures. It also has wireless connectivity, Ethernet connectivity, so you can work across teams, you can track jobs from everyone. You know, you can get notifications to your phone if your job is completed or if your resin's about to run low. And we also have these new print cartridges, resin cartridges, just like a 2D printer. So you can load it and it'll automatically refill the resin for you as you print. You just select your print cartridge and you load it into the back of the printer, slide it down like a normal print cartridge on a 2D printer, pop open the air valve, and then you can start uploading your print. And we have this new feature in Preform called one-click print. So you see I have a model loaded in my Preform software, and all I have to do is click this little magic wand tool here, and now it's going to automatically orient the part for optimum printing and generate supports. Generate the supports, and then it'll send the print job to the printer via wireless connection, and once it's uploaded, you just hit the start button on the front of the printer, and it's ready to go.
Let's talk a little bit about the tech, because stereolithography is still, it's a little bit magic to people who have never used it before. It is 3D printing, but instead of laying down layer by layer of ABS or PLA, I've got a photosensitive resin that is hardened as I hit it with a laser. Tell me the specs on this machine. How fine of a print can I get? How large of a print can I get?
Well, like the Form 1, you can do layers as fine as 25 microns. With this machine, we actually have a finer spot size on our laser, so it's down to 150 microns. So it's you can get better detail than you could on the Form 1. But it's also, you can do things that you can't do with an FDM printer. So you can actually do watertight channels, and you can do airtight parts. So if you wanted to do real engineering, like test fluid seals, air seals, stuff like that, we actually have some hydraulic components that have been tested on our machine, and as well as like millifluidic channels, microfluidic channels have been tested on our machine, and you can do really fine details that you can't achieve with an extrusion-based printer, because the limitation of that technology is the print head itself and the nozzle that the extruded plastic is being forced through.
One of the skills that makers are having to learn is which tool to use when. And for some jobs, a 3D printer is perfect, but where do you see this becoming more of a necessity? In other words, if you were to speak to the makers in our audience, when would you say you move from a 3D printer to a stereolithography printer and back?
I think if you're kind of approaching a final production stage in your product development, we've had, I think to date, 11 successfully funded Kickstarter projects from our customers, to the tune of about $3 million on Kickstarter. So these are people who are bringing real products to market. One of them is Sutru, which is a medical device company in England, where they're making an automatic suturing guide that basically runs the needle along the wound closure and makes a cleaner and faster healing wound closure for surgical processes. So they were successfully funded, and they prototyped everything on the Form 1 and the Form 1 Plus, including these like miniature rollers for the needle guide and everything like that. It was pretty amazing.
Let's give the brass tacks to the folks at home. If they wanted to look at a Form 2, where could they go, and when will it be available, and for what price?
Well, we're here at Maker Faire, so obviously we're going to have it here this weekend. If you're coming to Maker Faire, please stop by our booth. We're at PV01 in the 3D printing pavilion. I'm leaving from Maker Faire to go to Rapid Canada on Sunday night, so if you are one of our Canadian customers, you can come see me in Toronto. And then from there, we're going to be doing a pretty big multi-city tour. All the design and manufacturing shows coming up in the fall, we're going to be there, and a couple of jewelry shows in Miami, and also at SEMA. We're kind of like testing the automotive market in November. So if you're in Vegas in November, you should come see us at SEMA. As far as the price, we've actually packed it with all these new features that you would think would balloon the price dramatically, but it's only $200 more than the Form 1. So it's $34.99. €29.99 for our European customers. And, you get so many more features that you wouldn't have thought possible on the Form 1 Plus for that price. And it will be shipping in November. So orders placed today, you'll start receiving them end of November, early December.
And for the folks at home who won't be able to make it to one of your events, where can they go online to find out more?
You can go to formlabs.com. You can check out all of our printer specs online, or you can click to speak with one of our sales reps or one of our customer support team. We have an online chat tool on our website, or you can send an email to sales@formlabs.com, and someone will get back to you right away.
It's beautiful tech. Thank you, JP. Thank you very much for sharing the Form 2 with us. And folks, if you want to make, Formlabs wants to help you make with light. So if you're a maker, you've probably used your Dremel tools. This is the VRT1. It's a vacuum rotary tool. The idea is if you have a shop vac, like the one I have down here, you can use that to both power the tool and to keep your workspace free of debris. If you've ever used one of these tools, you know it can get a little bit messy. Quite simply, turn on your vacuum, engage the tool, and now not only can I use all of my attachments, but you'll see it vacuums up the debris from the workspace. This is actually a really good idea. If you have a makerspace in an area that you share with other people or that you really don't want to get messy, the VRT1 is for you.
All right, audience, one more time. 1, 2, 3.
Everybody loves a Rube Goldberg machine, and here at Maker Faire, well, we supersize ours. I'm standing next to Rose and Mark, who have brought the life-size mousetrap to the World Maker Faire here in New York.
You are now cheering wildly. Do you know how hard it is to make that happen, ladies and gentlemen?
I'm sorry, why mousetrap?
I used to play the game a lot as a kid, and then when I just got older, I wanted to create something really big, and people used to just, give me a hard time, and I'd say, I want to build a giant board game. And they'd say, you can't do that. And I said, the hell I can't. So I just went for it, and I built a 50,000-pound kinetic sculpture modeled after the 1963 Milton Bradley board game Mousetrap.
We have seen Mousetrap at Maker Faire in San Mateo, and it's always a draw. It's always one of these things that everyone has to see at least once because, well, the payoff is you crush a car. But what does it take to move this 50,000-pound piece of machinery from place to place?
Well, we got a 53-foot semi-trailer that costs us $2 to $3 a mile to move, so start adding that up from SF to New York. But, we have a great production, I have a really great crew, and it really boils down to being able to haul stuff out, and we use a big variable reach forklift, and Rose here is the forklift driver, certified, which is awesome. And we have a really good time. We set it up, and we like going to towns and science centers and fairs and showing people what we do.
Rose, I have to ask you, what is your favorite part? I mean, obviously, it can't be the setup or the teardown because that's torturous. But you do have a very nice sense of showmanship. You get the crowd into it. You show them the steps. You actually do teach. You teach about the transfer of kinetic energy. But in every show that you do, what's the spot that you like to be in the most?
I really love when we crush the car, of course.
Yes, ladies and gentlemen.
And really the fun part for us is right when we put it together, before the show actually starts, and we have to make everything work. And everywhere we are, it's a different situation, and that's where it gets exciting and fun. And we get to put into use all that practical knowledge of levers and what's this piece going to do and where's the ball going to go and what kind of hill are we on. And that's really the fun part, is when we get to make the machine run. And of course, when the audience cheers is always a fantastic...
Making people smile. Making the kids smile, the parents smile, everyone loves it. It's a lot of fun.
When you see those eyeballs get big, as people realize what it is, and they follow the chain reaction, and then they see that we're going to crush a car, and feeling like maybe you've inspired somebody to think a little bigger and do something a little crazy in their own backyard, that's really fun.
Now, last question. I mean, obviously, your Rube Goldberg machine is really scaled up. You're not using marbles, you're using a bowling ball. And actually, we just saw a completely successful first run. Congratulations. That's got to be incredibly difficult because you're disassembling this machine, bringing it over here. There's always a chance that it's going to get stuck. But for those makers out there who want to make their own Rube Goldberg contraptions, what advice would you want to give them?
I'd say perseverance. It took me 13 years to build this, and you just got to keep cranking. You got to keep doing it. You just don't take no for an answer. You get it set up, and if you fail, that just means you got to try again next time. So you just keep plugging away at it. And I like to say I would make Mr. Rube Goldberg smile. So he's not with us now, but he inspired me, and I hope I get to inspire people as well.
And I think for anybody interested in playing around with stuff, really play. Just have fun with it, and don't be afraid to try something wacky. It just might work.
If they wanted to find out more about the life-size mousetrap and where they can find you next, is there an address they can go to, maybe watch a couple of clips, see how the magic works?
Lifesizemousetrap.org is our website. We are also on Facebook, of course, and people can connect with us through the website and through Facebook.
You can also find us through the Maker Faire as well. We've got several pages of Maker Faire old stuff that we've been involved since 2007 with the Maker Faire. So there it is.
Rose, Mark, thank you very much. And I'm Father Robert Balliser here at Maker Faire. Be careful where you park your car. You've seen stock car races. You've seen tractor races. But here at Maker Faire, we choose power tool races. I'm here with Jim from Hive 13, who's going to explain why they're racing belt sanders and other dangerous machines. Jim, what's the idea behind this being a weapon of mass racing?
Well, we're all engineers and geeks, and in our earlier years we did Pinewood Derby. This is graduate school for Pinewood Derby hotshots.
I've been watching a couple of races, and yeah, people are kind of superstitious about which lane's going to win and which tool is better. Is there any sort of finesse to this, or is it just put the power on and get it to the end of the track?
Well, all drivers think it's the track's responsibility, but it really comes down to the thumb. Some people have it and some people don't.
So there's a little bit of a pulsing action. You don't want to just hold it down.
It's not all speed. There is some control.
This isn't just for Maker Faire. I understand that there are people who race this around the country. If people are interested in racing their power tools, how would they get into it?
Well, we came out of the Cincinnati hackerspace, Hive 13. We did this for our first mini Maker Faire 3 years ago, and we had so much fun. We do it at 2 or 3 races. We actually did it with Louisville and Columbus to make the Midwest regional triple crown of power tool drag racing, and we've come to New York City too.
I have to ask, is there a secret to the types of tools that you choose? Can any tool become a racer, any belt sander, or is there a specific class, a specific type, a specific technology that makes for a better racer than any other?
It all comes down to the individual racer maker's creativity. We do 3 types of racing. This is your generic Harbor Freight house racer, but we have a speed tournament where we encourage people to build their own racers. They can use angle grinders, circular saws, belt sanders, saber saws. People go for exotic racers. You can use a power washer and to drive a paddle wheel to move your racer down the track. You can get style points or just pure speed points.
What about, say, compressed gas?
Sounds good to me, but it's got to start from a handheld portable power tool with an electric motor.
All right, Jim, well, we're gonna race these down the track in just a bit, but if they wanted to find out more about your team, about Hive 13, or just about the sport of power tool racing in general, where would be a good resource for them to go?
YouTube works. There's YouTube videos under Power Tool Drag Racing or our Hive 13 Hackerspace website.
Thank you very much for speaking with us, and gentlemen, start your power tools. We're going to keep bringing you coverage from the world's largest Maker Faire, but first I want to take a moment to thank the sponsor of this TWiT Live special, and that's Braintree. If you're a mobile app developer, then you need Braintree, because it's the easiest way to work mobile payments into your project. Now, imagine this, 10 lines of code, an SDK that works across languages on iOS, on Android, and is quite possibly the easiest way to get paid. Braintree is more than just a payment solution. They're a peace of mind. They give you a sandbox so you can test your solution before it actually goes live. They give you tokenization of data so you never have to risk your customers' personal information. More than that, Braintree gives you support. If you have trouble with the integration, they'll actually have a support member stand with you and make sure that you get it done right. In other words, folks, if you're not using Braintree, you're working too hard. Right now, we want to give you an easy way to accept payments on your app. That's right, they'll accept Bitcoin, Venmo, Apple Pay, even Android Pay. Every kind of payment that your customer wants right now. And with that V.0 SDK, the implementation will be smooth, easy, and right the first time. Just go to Braintree today at braintreepayments.com/twit. That's braintreepayments.com/twit. We're continuing our World Maker Faire coverage by speaking with Becky Stern from Adafruit. She is, I'm going to say, you're the mistress of makers. You are the one who inspires people to get out there and just create things, specifically with the gear from Adafruit. Becky, how have you found Maker Faire so far?
Absolutely fantastic, as usual.
Now, we just watched one of your presentations when you were in the DIY Pavilion, where you were showing people how to use conductive thread, which I've tried. Tends to be a little tricky. I keep shorting out. What's the secret to using it?
Have you been sewing since you were 8 years old? Because I find that helps a lot.
I've been sewing for on and off for a month.
Okay, great. Well, practice makes perfect. That's what I would say.
I've also found that if I make clothes with conductive thread, I shouldn't bunch them up and then try to power it on because it doesn't like that.
No, because then your threads are crossed and you want to keep your circuit nice and flat since it's an uninsulated circuit, after all.
I mean, it sounds so easy now, but okay, yeah, I wasn't thinking. Now, let's talk about some of the other gear that Adafruit has brought. You showed off what I found fascinating. It was a watch-type device that had a GPS built into it, and that it had a LED ring light on it so that it could indicate by using 2 dots of what time it is. Is that the kind of maker project that you would suggest to someone starting out with more than just LED, something smart, something that utilizes things like a GPS module?
Sure, that's a good beginner GPS project, although it is very compact and therefore like a complicated circuit assembly. So that's from my book, Getting Started with Adafruit Flora, co-authored with Tyler Cooper. And it's the most advanced project in the book. So a simpler project would be using just one sensor instead of multiple sensors, like the Flora accelerometer, to make, say, a skirt that lights up when you dance.
What is your impression of the Maker Faire audience here? I mean, I know that Adafruit is also very, very much involved at the Maker Faire in San Mateo, but it's a slightly different crowd. I'd say there's a lot more young people here at the World Maker Faire. You also get a lot of international guests that you don't necessarily get at San Mateo. How have you found this crowd versus those that we might find in the Bay Area?
Well, the Bay Area crowd's already really techy, right? You got all of your startups and your Silicon Valley. That's like, and it's much bigger. But Maker Faire New York is growing. This is probably my 6th, 7th, or 8th Maker Faire because I used to work for Make Magazine. And yeah, this crew, it's a lot more diverse, I would say, like in terms of background, both ethnically and topic-based. And there are a lot of young people, a lot of families, but also like your teenagers with funny colored hair. It's a really diverse and inquisitive crowd here in New York, yeah.
The other thing I noticed, and this is our first time at the World Maker Faire. We've done San Mateo forever, but this is huge. I mean, I thought San Mateo was big, but we were walking over to the Mousetrap and over to the EP Bird guys. How large is this fair, and is it going to get much larger than this? Because we already can't cover it in 2 days.
I agree. I'm not sure. When I first started here, I was at the first New York Maker Faire in 2010, and now they've expanded to multiple grassy areas. You see every year they negotiate with the park to eke out another little area, new area, where Cycleside or the aerialists are. And so every year they kind of make it with a new area. And eventually, couldn't it take over all of Corona Park? I mean, New York City pride, right?
Well, Bay Area pride. Woot. All right. One last question, and that's this. I've noticed we've sort of turned the corner. I think the maker generation, the maker revolution is growing up a little bit. It used to be all about make something, share something, inspire something, and that's still there. But I'm seeing more and more entrepreneurs jumping into the game where they're saying, look, I can make something, and if it's really popular at Maker Faire, it becomes a product. It becomes something that I can market. It becomes something that I can get backing for. Do you think those two can live with each other?
Sure. I think that one is kind of a gateway into another. So you can start making as a hobby, and then if you find that that's your true passion, it's really interesting to see that now there's a big enough audience that you can find funding and support, even crowdfunding for your project. So that's a fun avenue for people to go, even if it doesn't become their main business. If you can, subsidize your hobby, that's a really good thing that has come out of the growing audience of Maker Faire and the maker movement in general.
I believe that the stat being used was from Maker Faire, the 2 Maker Fairs last year. The attendees who started Kickstarters received over $15 million in funding. So there's something there. Becky, I want to thank you so very much for speaking with us. Now, if they wanted to find you and find your products and your projects, because they're fantastic, where can they go?
Adafruit.com/Becky Stern. I do a live wearable show every Wednesday on YouTube at 2 p.m., and we release new wearables projects every single week. Check out our learning system, learn.adafruit.com. There's over 800 electronics tutorials there for free online.
It's Becky Stern from Adafruit, and now that she's told you how to make it, go make it. Makers have a wide range of tools that they can use. CNC milling machines, laser engravers, and of course, 3D printers. But all of those tools need to start with design, which is why we're speaking with Mark from SketchUp. He's going to tell us what we need to turn our imagination into something in the real world. Mark, what is SketchUp?
Well, great question. You almost took the words right out of my mouth. We think that in order to build something great, you need to draw something great. So SketchUp basically is the easiest way to draw something in 3D. It's 3D modeling for everybody. If anyone has experience with 3D modeling software at the industrial level for product design like SolidWorks, there are some really, really powerful 3D modeling tools for industrial prototyping, for engineering, mechanical CAD. But SketchUp is the simplest, most effective, most productive 3D modeling that you can learn today. So if you want to be productive right away, SketchUp's for you.
Now, what tips can you give to the people who are starting design? Because it can be a little daunting. There's a lot of tools. There's a lot of different ways you can go about creating any particular object. If you've got someone out there who has never designed anything in his or her life, where should they start?
Well, you should start by learning, and actually having a project that you want to create is a great place. But just like everything, the first thing you build will not be the right thing. So you kind of want to approach your first project from a learning perspective. So you are going to learn SketchUp. We've got a great series of getting started videos, sketchup.com/learn. But as you're learning to draw in 3D, give yourself permission to screw up. In fact, probably I should have said in order to build something great, you need to draw something great and then screw it up a couple of times.
Can you actually show us what it looks like? What does the interface look like, and what steps are you taking?
Absolutely. I'm going to come back to this project you guys are seeing right here. This is the Maker Bench that we're working on this weekend. Let's start with a new 3D model file, though. And you can see in SketchUp, I'm going to get going really quickly here. You start with the line tool. And as you're drawing in 3D, SketchUp will give you hints along the way. So, for instance, I know this line is now parallel to the green axis. Again, here it's parallel to the red axis. And then I can actually reference other points, like the midpoint of that line segment, or connect shapes to create faces. And then it's a simple click on the push-pull tool here to extrude shapes into 3D, to move around, create other shapes, and then it's very quick actually to start creating more complex geometry. You don't really need to worry about formulas or vectors. You just kind of draw the way that your brain thinks about shapes. You can absolutely be as precise as you want in SketchUp, but when you're starting, we like to make it really like drawing, like freehand. So when you start to learn in SketchUp, you can go freehand, and when you start to get to the point of, you know what, I actually need this thing to be 3/4 of an inch because that's what the plywood actually is, you can do that as well.
Quick question. Is there a difference in how I design something that will be printed on a 3D printer versus, say, a CNC milling machine or a laser engraver? In other words, can I take one design and push it out to all my tools, or do I need to think tool specific?
I'm sure you've heard this answer before, but it depends. But I will. Let me see if I can go to a broader level and give you guys something useful. When I design for 3D printing, I typically don't do it at scale, which means that I know the build plate dimensions, and at some point, if I'm going to print my object, I need to decide if it's going to be all on one build plate or if there needs to be connectors. But when I design for 3D printing, I go to a bigger scale because sometimes those really small pieces are harder to model when you are at that micro level, right? And there are some great tools for cleaning up your model when you bring it from a big scale down to a small scale. They're both free. They're called Solid Inspector 2 and Cleanup. And both of those are free tools, free extensions for SketchUp that you can find. They're essentially like apps for SketchUp that you can download while you're using the program. When you're designing for CNC, that's when you want to start being a little bit more precise, right? So you may have a conceptual stage, but ultimately you want to be have a level of precision. One of the things that we do is we advise people to use components, which are essentially copyable modules in SketchUp. So you can be working on a project like this this maker bench right here, and as you're configuring or changing something, the individual pieces which are actually laid out on the cutting sheets are also changing. So if I make a modification to the table leg in the as-built design, that modification also gets replicated to the working cutting sheet.
Mark, thank you very much for speaking with us. If they want to find out more about SketchUp, where they can pick up your software, where they can start designing, where can our audience go?
SketchUp.com. Take it for a spin.
Father Robert Ballecer, remember, imagine it, dream it, then sketch it. And draw it. The Roomba made it acceptable for you to put a robot in your home. I'm here with the inventor of the Roomba, Joe Jones, who's going to explain why your next robot will go in the garden. Mr. Jones, what is this?
This is a weeding robot, and we're here at Maker Faire testing it out. It's a robot that's designed to live in your garden. There's solar cells on top of the robot. It collects energy from the sun. When it collects enough energy, it goes out and weeds the garden.
You've got a very interesting navigation system on this, much like the Roomba, with one main difference, and that is it's designed to bump off of and change direction from plants, the ones you actually want growing. But when it runs over a weed that's small enough, it activates a weed whacker underneath and takes it down to the ground?
Yes, that's basically it. We have a sensor behind the front bumper there. It's a capacitive sensor. And whenever it encounters something which is tall, like a fence, like it's bumping into now, or a tall plant, it turns away. But there's another sensor on the bottom of the robot, such that if any plant goes underneath the robot, then it turns on its whacking mechanism and grinds it up.
Of course, each of these will be able to handle a certain amount of space. How much can one robot handle? Given enough light, how much can you expect one robot to be able to weed whack?
Right now, we don't know that number exactly, but you can be sure that it will be enough for an average garden.
So the idea is buy yourself a swarm of these to cover a large area and just let them go. I should be able to put one of these out in the open air, out in the environment, and just let it do its thing day after day. I don't have to worry about it charging because it gets its light from its power from the sun. I don't have to worry about maintenance. It just goes until it can no longer go. And I don't have to worry about telling it what it can and cannot cut because you've built in the avoidance system. So what's the next step? How do you bring this to the market?
Well, we're working on that right now. We don't exactly know what the next step is. The first step, of course, is validating it at a place like this to put it out in front of people and see what they think of it. Or if they're telling us that there's something very different that we should do with the robot, well, we'll make that change before we try to turn it into a product.
Now, if our audience wants to find out more about this robot or more about what you're working on, is there a place on the internet that they can go?
You can go to franklinrobotics.com. That's our company site.
Mr. Jones, thank you very much for speaking with us. Thank you for giving us the Roomba, and thank you for giving us the future of green robotics. Fast prototyping is the cornerstone of the maker spirit. And sometimes you need something like this, the Orion, which prints incredibly quickly, but doesn't really have all that big of a build space. Let's move from this to the Rostock Max, which is quite a bit bigger, but still there are going to be makers who want more. Sometimes you need to print really big, which is why we've got the Part Daddy, and I'm standing next to Steve, who's going to guide us through some of the finer points of this monster 3D printer. Steve, what is this?
This is, I called it the Part Daddy. It's a 17-foot tall Delta printer, and Delta is because of the 3 arms, and it's a good example of scaling up the technology. And basically, it can print about 4-foot diameter by 9.5 feet tall. So you can get a really large part off of it. I have printed a large clock 9 feet tall. Amazingly, when you come up to this printer and you look at it, it's like, wow, it must be controlled by something really huge. No, it's Ultimachine's Rambo board that we use in our little printers is actually running this great big printer. So it's another thing that surprises people when they come up to it.
One of the amazing things about that is, yes, even though it is bigger, it's essentially just a scaled-up version of your smaller Deltas, and it can do something like this in an hour. It did this the first time we stopped by, and now it's all done.
Yeah, this print here I did just a little bit ago. It's only 45 minutes, actually, and it was just to warm it up, make sure everything's working right after we set up. We drove out here from Indiana, and it took us about an hour to get this thing running.
Something else that is fascinating about a large format printer like this is you don't have filament like we do on smaller printers. You don't have rolls. You actually have pellets. This hops in pellets of material and then makes its own material.
Yeah, so there's a little $20 shop vacuum on top here, and there's a sensor that detects the resin pellets. It vacuums them out of that trash can behind the machine and augers them into a 4 millimeter wide stream of plastic, extruding to make that big of a stream, filament. It's actually making filament, I guess is what I'm trying to say.
This is very cool, and yes, I like to see technology like this at Maker, but let's take a look at some of the printers that are really sort of the bread and butter of See Me CNC, specifically the Rostock and the Orion. Over here, you've got more traditional deltas, more down to the size that we would expect. Tell me a little bit about the Rostock and the Orion. Why use a delta configuration, this 3-post, rather than the traditional crossbeam?
Well, one of the biggest advantages, as you've seen on the large printer, it's better for your print to be stationary. The deltas are very good at moving quickly in all 3 directions all at once. So you can go X, Y, Z, and you're there. As far as the print being stationary, like you saw, get large print, it doesn't move around in any direction, just your print nozzle. So the Rollstock Max V2 is our flagship product that we started with back in 2012. It's we were the first manufacturer to sell the Delta printer, and it was based on Johan's work out in the metrics maker space that he's involved in. He was the guy that first made this technology work in the open source realm. So it makes us a really great example of what open source can do and the community can do in a short period of time. It was only 2.5 weeks from beginning to end, no printer to running printer, with help from the community and lots of people.
Let's go from the Rostock to the Orion. This is your flagship. This is a beautiful printer. It comes pre-assembled, pre-configured, and it prints pretty much everything. It will do PLA, it will do ABS, it will do NinjaFlex, you name it. Why go with a smaller version than the Rostock?
Well, we wanted to assemble. The Rostock is a kit that you build, and under special circumstances, we'll ship a large Rostock assembled. But the little Orion, it ships better. When they handle those boxes and getting from point A to point B, they're a little rough on them sometimes. So this little guy travels well through the various shipping methods we offer. Now, the Orion you see here is our latest revision. We're always adding upgrades like these clear carriages and that. We're always improving our product as we continue on our journey. So, yeah, this little guy is a very popular printer for people that want an already built machine.
Steve, give us prices and availability. So I know that this one's going to go, what is it, about $1,000, $1,049 or so?
Yeah. Yeah, the little Orion is about $1,049 pre-assembled. Our flagship product, the Rostock Max product, is $999 regular price. And the newest little Delta printer we'll have out in the background here is this the Eris, and we will have that printing tomorrow, and you can check it out. That little guy is aimed more towards the retail consumer that wants to get into it but doesn't want to spend as much money. So we got the $599, a $1049, and then a $999 kit.
Steve, if they want to find out more about See Me CNC, where can they go?
They go to seemecnc.com, and they can check our products out there.
I'm standing next to Mark Kornblatt from Game of Drones, which is now becoming the Aerial Sports League. Mark, why ASL?
Well, we found that after a few years of playing with our drones and doing drone combat, the idea of drone sports really emerged into its own thing. And so what we started doing as marketing and community outreach really became the core aspect of our business, and that is the sports and the league, the combat, but now also including FPV racing. And so it made a lot of sense for us to emerge into the Aerial Sports League and actually take the Game of Drones hardware business and absorb that into it. And so now Game of Drones is actually the ASL certified hardware arm.
Understood. Now, Game of Drones was fun because we got to see people fly drones in a demolition derby style race. you've added finesse. ASL is really about piloting skills, about building something that can endure, that can take corners, that can really eke out every inch of speed possible. Tell me, how is that a change from what you've done previously?
Well, when we first started with the drone combat, as you described, it was relatively simple. In a small arena, the two drones would battle each other in the air until one of them finally crashed. And then the interesting part of that was all the engineering that would go into fixing that drone really quickly under a countdown clock to get it back up in the air and continue the game. What we found, though, was the engineering was a large part of that, and the piloting was about a 50-50 split. In the racing, well, there's certainly engineering that's required, but really it's more about the piloting, the pilot skills, and that pilot experience. The racing involves wearing goggles so you get a first-person view, and that's a real transformative experience for the pilot. Once you start flying in that first-person view, you almost never want to fly line of sight because it doesn't have that same thrill. And so we found that as the idea of drone sports emerged, or evolved rather, that the desire to be that pilot and be in the cockpit of the drone was such a strong desire that it really changed what the people who were involved in the sport, changed what they were interested in. And so now you have a real good mix of engineering, development, but especially piloting skills. And it's remarkable to see within about 1 year of drone racing as a thing, it's remarkable to see the skill levels that have come out of pilots of every age and every demographic group. And some of the best pilots out there right now are kids.
Oh, I have to say, I've loved watching Game of Drones. I've seen you at Maker Faire. Of course, we had you at the TWiT studio. And I love this racetrack that's behind me because it really is expanding what we're expecting out of people who are flying. It reminds me a little bit of what we saw in the early days of cyber competitions. You had these groups that were coming out with their own leagues for people who wanted to compete in video games. And it wasn't paid that much attention, but now, of course, it's huge. It's a multi-billion-dollar industry. I get the feeling that drones, drone racing, drone combat is headed in the same direction. What do you think that ASL is going to offer that maybe some of the other leagues that are starting up right now might not have?
Well, that's a really good question. There's a lot of different groups and leagues out there. There's communities that are starting. There's businesses that are starting. There's worldwide competition organizations that are starting. And so there's a lot of different approaches to the strategy for how to build a drone business. We've always been very focused on entertainment. We've always been a media brand from the get-go. And so more recently, when we started working with drones, we sort of folded that into our philosophy of being a media brand. And so we have a large community, but really we reach out to that community through Facebook and YouTube, increasingly through big live events like this. And we're always really focused on the audience experience. While I described a moment ago about that thrill that the pilot gets, the audience doesn't always get to experience that themselves, and so they're just watching these small drones going around in a circle. So we've done a few things here by putting it into a relatively small arena. We make the pilots fly very precise. The entire arena is visible from the audience at all times so they can have a good viewing experience. And we're also going to be setting up video screens for instant replay, and we'll be streaming these videos to the web. And so we're creating like a media brand that you can participate in even if you're not at our live events.
Mark, thank you very much for speaking with us. Now, if they wanted to find out more about ASL, where they could fly, and where they might be able to see your races, where can they go?
Sure. Go to aerialsports.tv. You'll be able to sign up there. You'll be able to sign up as a pilot or find a local group to fly with and get all the information you need to start your world of FPV racing.
I'm Father Robert Balliser. Make it, build it, then fly it. Makers are all about 3D printers, but if you want precision, if you want strength, nothing quite beats CNC, which is why I'm speaking with Ted Hall from ShopBot, who's going to explain how you can get precision out of one of their handybots. Ted, thank you very much for speaking with us. What am I looking at?
Well, you're looking at a very small CNC tool. We think of it as a smart power tool. It's got intelligence and something that you can pick up, put down on a table, put down on your work material, put down on a board, or in this case, we put it on top of an accessory that has an additional turning option underneath. I couldn't have said it better myself about 3D printing is great, but sometimes you need to make stuff with real materials that can scale as well. And we think this little tool that combines a lot of precision and power is one way to get at that.
I love the fast prototyping of a 3D printer, but as we all know, putting down material layer by layer isn't the strongest process that we're going to have, and it doesn't create all the parts that I might need for a manufactured process. But can you guide me through what kind of materials I can print with? I see we've got wood here, we've got acrylic, we've even got aluminum. What kind of experience do I need in order to be able to properly machine these materials?
Well, you're right. One of the advantages of the subtractive technique is that you usually have a wider range of materials available to you. And with HandyBots, wood, foam, plastics, acrylics of one sort or another, soft metals like aluminum and brass copper are all machinable. You can make printed circuit boards, that kind of thing. The skill level is a step higher than people often conceptualize 3D printing. There's a little bit more than click to print. But increasingly, the tools from getting from a CAD drawing or a model of what you want to make to the actual part are getting better and a lot easier to do. And so we're thinking, yeah, it's one step harder than 3D printing, but it's well within the grasp of anybody who's at all comfortable with drawing or creating in CAD.
I look at something like this, and this is a beautiful, beautiful milling here. I wouldn't be able to get this with a 3D printer. Even the highest precision 3D printer would leave ridges that I'd need to sand down later on. And this is a finished product out of the mill. What kind of steppers do you have in there?
Well, we have very traditional open loop steppers that give the tool the precision per step of about 1/4 of a thousandth of an inch, 0.00025. And that allows, just like you pointed out, incredibly precise machining. If you put on your second pair of glasses, you can see that there are actually milling marks here from the passes the tool's made. But it's very fine and very smooth compared to what a 3D printer gives you.
All right, big question. Our audience is going to want to know, if they wanted to start in CNC and perhaps start with one of your smaller units, what is it going to run them? And then how far can they go if they wanted to start building larger objects?
Well, these tools cost $2,800, $2,795. We've been selling them for several years, and we think that's a great way to get into CNC just because of the range of materials and kind of work that a HandyBot will do. And you can do much bigger pieces by taking the tool and tiling across a larger area. But at some point that gets inefficient, and if you're really looking towards cutting large sheets of plywood or something like that, you want a CNC tool that's got a larger format to it.
Ted Hall, thank you very much for speaking with us. Now, if they wanted to find out more about the HandyBot, where they might be able to pick one up, or maybe where they can get something fabbed by one of your partners, where can they go?
Well, you can find out all about HandyBots on the HandyBot website if you don't make it to Maker Faire here this weekend. So it's handybot.com, and there's all sorts of samples and videos of the tool in action. ShopBot sponsors a larger network of digital fabbers that include people with CNC tools, 3D printers, laser cutters, and the network is called 100kgarages.com, 100,000garages.com. You can go to that on the website and find somebody in your neighborhood who will help you make something with digital fab. We'll teach you how to use it and help get you involved, or just make your parts for you.
Again, Ted Hall, thank you very much. If you're a maker, give yourself a hand, D-Bot. There's a lot of technology here at Maker Faire we like to look at, but none as much as the stuff that you can build, which is why I'm speaking with Eric from Strawbees. He made this, and he encourages people to make things like this. Eric, this is just a bunch of straws, some cardboard, and a motor. What did you build?
This is like 50s technology. This is a hovercraft with cheaper materials than you can, that's the thing. It's commonly available trash. So we like toys that are easy to make, and so you can make, instead of making one thing that works and you don't know exactly why, you make 5 things. 3 of them work really well. 1 works like it's crap, and the 4th is okay. 5. You have fun with it. So.
Well, that's the maker spirit. The maker spirit is take something, try it. When it breaks, improve it. When it breaks again, improve it. Tell me, when I look at this, first of all, I'm looking at a garbage bag taped to a piece of cardboard.
Yeah, this has a lot of different technology on it. Technology, garbage bag. technology cardboard. These are common materials. Technology strawberry connector. And then 3D printed stuff here, a brushless motor. So there's like a mix of stuff.
What really makes this, though, is that you've created a system that allows people to rapid prototype. The strawbees are these connectors that you see all around the structure so that I can disassemble it, reassemble it, drop it on top of another structure as quickly as possible and test out as much as I want.
That's the most important part, the iterations, like playing with different designs. And then you're like, I wonder what happens if I have a circular hovercraft. Well, you make it. It takes a couple of minutes to cut out the circle. And the second thing is double-sided tape on the piece of trash bag, and then try it out. Give it a go.
Let's look at some of the things that you've created for us. Not only is this a motor on top of a cardboard box with a bunch of straws on it, but you've also made it so that I can have a hovercraft with only one fan because you've got a bypass, you've got a diversion.
You can see the thing here. It's just a cardboard little flap that folds up, and you can see it's quick and dirty solutions here, which is what we want. We want it to be easy to improve. So when we show designs, it should be easy to improve for everybody. Anyway, so the air comes from the propeller and from your speed, forward speed. In here, pushes it out into this skirt here. And there are, on this particular one, there are 4, you might see them there, you see holes. That's where the air comes out. So this is a one-way valve for air, which makes it so efficient even without the motor on. And the 4 holes here. So air gets pushed out. It hovers very, it's very low height. This is a very tight little skirt, so you can try different designs, which is so much fun. When you try out a shorter one, what happens then? Instead of like saying, no, that won't work, try it. You lose half an hour of your life and you learn something. It's okay. So you're not really losing that hour. And then you know how I told you a little bit about how it came to be. It was because we just wanted to try out different ways of reducing friction. So this is it's also a curling set, you know, the ice. So we figured it's expensive to make ice in here. So how can we make the same? Let's turn this surface into ice, and then it's just reducing friction through the air layer that we make. So we can just slide this without the motor on.
That's fantastic.
So that's a way of talking about friction, like reducing it, trying it out, and then, yeah.
This is the sort of stuff that I love seeing at Maker Faire. Now, I'm going to ask you to drive this in just a bit to say goodbye to the folks. But before we do that, could you tell them where they can find you, where they can find Strawbees?
They can find, my name is Eric, and they can find me on strawbees.com. And these things are all open source. So everything, if you have a laser cutter, a vinyl cutter, you can download the files for the Strawbees. You can also buy them there, but, you know, we want people to start making and prototyping. So we call this a prototyping toy. So, yeah.
Make, prototype, Strawbees. Eric, go ahead and do us a favor and give us a victory lap. So you've got music. What comes next? If you're at Maker Faire, the answer is fire. I'm here with Olivia from Gorilla Science, who's going to explain why we've got flames shooting out of an organ. Olivia, what is this?
This is the fire organ.
Now, what does it do? I mean, I understand you have it hooked up to an organ here, but why do the flames shoot out?
So the fire organ is based on 100-year-old technology. So Heinrich Rubens invented what is called a Rubens tube in 1905. So a Rubens tube is a metal tube that has gas flowing through it, holes at the top, and a speaker on the end. So we have 5 Rubens tubes here. When the speaker produces sound, in this case from an electric piano, the speaker changes the gas pressure within the tube, therefore creating flames shooting out the top. And the flames that are shooting out actually correspond to the frequencies of the sound that you're hearing. So you can actually see the sound wave of the music that you're hearing.
That's the amazing part. If you watch the tubes long enough, you can actually see the waves, how they come through the tubes. The lower the frequency, the longer the wavelength. The higher the frequency, the higher the wavelength. It's a fantastic way to show off how sound waves work inside of an enclosed structure. Tell me, when did you come up with the idea of making a Rubens tube into a fire organ?
So my colleague actually came up with the idea. He's a mathematician, and he had played around with Rubens tubes in demonstrations in the classroom, and he thought, hey, what if we made one with 5 instead of just 1?
Olivia, thank you very much for showing us off the wilder side of Maker Faire. If they want to find out more about Gorilla Science or the fire organ, where can they go?
Go to gorillascience.org or follow us on Twitter at Gorilla Science or Facebook.
There you have it. Music so funky, it's on fire. Space showers and toilets and gloves. Oh my, we're here at NASA Maker Faire 2015 in New York, and I'm speaking with Sam Ortega, who's going to explain why NASA has come to the Make. Sam, what's NASA doing here?
So actually, the whole maker media culture is the exact demographic that we're looking for. These are the people that NASA really strives to attract and to get engaged with. They're creative, they're innovative, they're smart. These are the kinds of folks that we're looking to help make them greater awareness of the space program that belongs to them. Our NASA space program is the People's Space Program. And so we want them to be aware of how they can get engaged. So we have many organizations from NASA here today at the Maker Faire for this weekend. We have prize competitions. We have some of our programs that do game-changing development. We have our technology demonstration type programs. We have people here from Kennedy Space Center. We have people here from Ames Research Center doing CubeSats and small satellite technology. So all of the organizations are here to help get makers more aware of exactly what NASA does.
One of the connections I really love is the fact that Maker invites the tinkerer. It invites the inventor. It invites the young person who's imagining what the next level of technology may look like, even though we have no idea where it may lead, which really harkens back to the early days of NASA, that you were creating things that never existed before. And so there is that sort of spiritual connection. But what are you hoping to inspire here? Because I look around your space here, and you've got everything from actual astronaut gloves to a waste management system to a shower system. What do you want to inspire in the next generation of makers?
So what we're looking for is we have certain technologies that we realize are going to be very imperative to doing future space exploration. It's going to be additive manufacturing. It's going to be a new technology development. So we want people to engage and be a part of that. We want them to get excited about this technology. And then we want them to find ways to help NASA grow and get rid of those technology barriers. So one thing we have our Centennial Challenges program. So that is a program where we do competitions for millions of dollars, and we look for exactly this: makers, hackers, innovators, creators, artists, retirees, high school kids. We don't care. We don't care who the solution comes from. What we want is that technology advancement, that technology solution, and we'll award prize money for that in the millions of dollars. We have other programs through our NASA Tournament Lab. So we have representatives here talking about the prize competitions that we do, and there are the contests that we do where we have tens of thousands of dollars, and those engage in people for maybe 3, 4, 5, 6 months to help develop new technologies as well. Some of our other programs, they will put out a call for people to submit ideas on an annual basis, and so we want them to come and be aware that if you have just a far-fetched idea, but you think that it would be something that could be of use to NASA, we want you to be aware that you can submit those proposals as part of our call and be engaged and be a part of the space program.
Sam, if you could reach out to our audience and inspire the young people who may be looking at this and thinking, I want to get involved with NASA, what would you want to tell them? Where would you want to tell them to go? And what would you tell them is going to be their inspiration for taking us to the stars?
Sure. So for our young makers, if you go to www.nasa.gov/solve, so that's SOLVE, and at that location, that's where you'll find the places where you can connect. And what I want people to really understand, whether you're a young maker, whether you're an old maker, whether you're an artist, that, again, anybody can help solve science and space technology problems. And in fact, we have awarded just shy of $1 million to an artist from New York City who has his own art studio there in the Brooklyn Navy Yard. He makes production pieces for Cirque du Soleil. He makes production pieces for Broadway. And he actually built a better astronaut glove than what NASA currently had. So we probably wouldn't have awarded him a multi-million-dollar contract to develop the astronaut glove, an artist out of New York City. But through the prize competition model, we were able to find him, we were able to work with him, and now we have given him a contract to go off and help create better astronaut gloves. And he actually took his prize money, rolled it over, and started a spacesuit company. So he manufactures spacesuits that he sells to private companies here in the New York area.
Sam, thank you very much for speaking with us. I'm here at Maker, and NASA wants to put you on the frontier to space. For precision, nothing beats lasers. Now, the laser game, as far as etching and cutting, has always been a little cost prohibitive. Some of the more advanced units have been running $20,000, $30,000, $40,000. Well, Glowforge is here to change that game. I'm speaking with Dan, who's going to explain what they brought to the show. Dan, what do you got?
Thanks so much for having me. This is a desktop laser, 12 by 20 cutting area, 40 or 45 watts available, but the real magic is that we put Wi-Fi in it, and we brought all the hard processing up to the cloud, which let us lower the costs down to under $2,000 for the basic model, and lets us add all sorts of crazy features, like the onboard camera can identify your MacBook, set the proper engrave settings, bring up a template so everything's centered perfectly. You can bring in materials that we provide. It'll scan them and pick up the an invisible barcode and set all the materials settings, or you can bring your own materials and save them. You can do things like, from your iPad, drag your design onto the material wherever you want it to be, hit print, and off it goes. You can even draw directly onto the material, and it'll engrave over the top of the ink and then cut out the perimeter so kids can make toys. We had an amazing illustrator who worked with Faire Games and helped us do a licensed Settlers of Catan set, which I can show you over here. And it's just beautiful. You can do anything from CAD all the way down to a doodle and make something amazing out of it.
That part is absolutely amazing. The ability to basically put a template over the top of the material that you're trying to engrave, and the laser will just follow. This reminds me a lot of where 3D printers were, say, 2-3 years ago, where they were still kind of jury-rigged. There weren't a lot of real good commercial units available, and they just kept coming down in price and up in quality. I think you're at the front of that. Now, tell me, what needs to happen for this to become the tool that every maker will have?
We're off to a good start. We opened pre-orders 2 days ago, and when I left the hotel this morning, we were at $2.2 million in pre-orders. So it was a good opener. And really, for us, it's so gratifying. We thought we knew that there was demand there, and to see people come out and say, yes, we want this, we need this, let's go make stuff together, nothing is more exciting about that. You know, I sometimes think it's almost as if the whole world didn't have kitchens and everybody was buying fast food. What is the world going to look like when you can make the things you want? You can make a shoulder bag, you can make a toy, you can make a dollhouse, you can make a drone, and you can print what you want, the way you want it, right there for less cost than you'd buy it online. That is what I'm excited about bringing out, and I'm really excited to be here at Maker Faire to show it to folks.
All right, let's get down to brass tacks. Let's say I've got one of these in my maker space. I want to engrave something. What are the steps that I would have to do? I mean, literally take me through what I'd have to do to engrave the laptop lid that I want to show the TWiT logo on.
So you have two choices. The first choice is you put it in, you open up the interface and you say scan. It will say, I see that you've got a MacBook Pro. Which template would you like to use, or would you like to use your own? You pick one and you hit print. That's option one. Option two, this is going to sound weird, you can write on your MacBook Pro with a Sharpie. Put it in there and say, go over the Sharpie with the laser. That's option two.
I love it. Now, this is fantastic technology. If they wanted to find out more about where they could pick up a Glowforge, find out maybe what's going on with the pre-orders, where can they go?
So for the next 28 days after Maker Faire, you can go to glowforge.com and get one of these for as little as $19.95 for the base unit. And I'll show you some of the things we made with the base unit. It's pretty incredible.
If you're a maker, you probably know what this is. It's a Raspberry Pi. This is the A variant. But Raspberry Pi has some unearthly news for the show. I'm standing next to Matt Richardson, who's going to explain that they've got a Spaceberry or AstroPi. What is this?
So we have the AstroPi program. It's a program for kids to write code that will run in space. This here is a piece of equipment, has a Raspberry Pi inside, a bunch of different sensors. 2 of these are going up to the International Space Station, and kids have written the code that will run on the Raspberry Pis up in space. It's a chance for them to run their own experiments on the International Space Station.
What kind of experiments will they get to do? I mean, what will the code interact with? What kind of sensors do they get to play with?
There's a bunch of different sensors: humidity, temperature, pressure. There's a gyroscope. There's an accelerometer. So the things we're seeing are mostly fun experiments. There's some games. There's a reaction timer kind of game to see if the astronauts are reacting differently over the course of the whole mission. There's also a one where a little more fun, where it'll just show a flag of the country that they're flying over, so that the crew can see where in the world the space station is flying over.
Let me see the sensor itself, because I understand that they can buy it. If they wanted to experiment with the same gear that's going to be going up to the ISS, they can get it right now. What is this? It's just a display? What can they play with on this board?
Yeah, we call this the Sense Hat. It has a 8x8 RGB LED matrix, that's the display. Has a little joystick, and it can display messages like that. And there's sensors on it: temperature, humidity, pressure, accelerometer, a gyroscope. I could give demos of all of that too. This is our little message to Maker Faire. And then, here's an orientation sensor demo, for instance, where it keeps the logo upright. And then, of course, I'll show you it can give you the temperature as well. This is a great way for people to experiment with temperature logging, to experiment and maybe even run the experiments that were run in space and try them down here on Earth as well.
Will that work on all variants of the Raspberry Pi?
Yes, it will.
And how much, if they wanted to pick one of these hats up, how much would that cost?
$30.
Okay, now the Sense Hat is not the only thing that you've brought to the Maker Faire. You've also got this beautiful official touchscreen, not a hack-together one, but one that will work out of the box. Tell me about this.
We've had a display connector on the Raspberry Pi since the very beginning, and we finally have a display for it. It's a 10-point multi-touch screen, 7 inches. It's beautiful. It runs, the Raspberry Pi mounts right to the back of it, connects over this display connector, and you can do 10-point multi-touch. This is an example we wrote with Python to be able to show off how amazing this display is.
If they wanted to start integrating with that, what kind of modules would they have to load up, or would my base package just work?
So out of the box, the base package will work. You'll be able to get up the desktop environment and log in using the screen. I recommend checking out Kivy. It's a Python package, a library that you can download to be able to do all this on-screen drawing, to be able to make elements, to be able to respond to touch events, gestures. It's a great library, and that's what I'm using in this demo here.
And if they wanted to pick up a touchscreen, how much would that set them back?
$60.
Fantastic. Matt, I got to say, every time Raspberry Pi comes to one of these events, you always got gear that I want to bring home. Could you please tell the fans out in the audience where they can go if they want to get themselves a Sense Hat, if they want to get themselves an official touchscreen?
If they go to raspberrypi.org, there'll be a shop logo, or you go to swag.raspberrypi.org. Everything's available for sale there.
Thank you very much for speaking with us. And of course, this is Raspberry Pi in space. From cardboard constructs to 3D printers, from laser etchers to microprocessors, Maker Faire has something for everyone. There are always those people who ask us, what are the trends? What are the products? What's the next big thing coming out of Maker Faire? But that's not really the mission of Maker Faire. Maker Faire is all about play, because it's in our play that we find our passion, we find our imagination, we find our inspiration. It's in that we find the next generation of makers. I'm Father Robert Balacer from TWiT TV saying goodbye from Maker Faire 2015, the greatest show and tell on Earth.